In this video, we're going to talk about confidence intervals. In particular, we're going to focus on looking at the confidence interval for a population mean. So let's just talk about what a confidence interval is. Suppose you are interested in renting a two-bedroom apartment in your town and you go to the newspaper, you look at several listings, you average them out. That's going to give you a point estimate for what the mean cost of a two-bedroom apartment is in your city. If you're trying to determine the percentage of times you make a basket when shooting a basketball, you'd count maybe the number of shots you'd make and then divide it by the number of shots you actually attempted. And that would be another point estimate, uh, measuring the proportion of times that you make the shot. So, what we do with a confidence interval is we have these ideas of estimating parameters. So, you might recall all the way back in chapter one, a parameter is a numerical summary of a population. And there are three types of parameters we are interested in possibly summarizing: the mean, a proportion, like the percentage of shots you make when you shoot a basketball, and the standard deviation. Now, the statistic, that is the numerical summary of the sample. So it's the sample's equivalent to the population. So you know that when we're estimating a sample mean, we use X bar. When we do proportion, we will be using the symbol P hat. So it's P with the little symbol over the top. And then instead of sigma, when we're talking about standard deviation, we use S when we're talking about a sample. So what we do is we often use these as a way of estimating the actual population parameter. So we call these point estimates. So we use them to stand in for the population. And of course, the more data we have, the more accurate the point estimate is. But whenever we look at a point estimate instead of the parameter, we're going to have a possible error to it. And we're going to talk about that a little bit more in detail. Before we do it, what we're doing right now is a very important part of statistics. This is called inferential statistics. This phrase was also used in chapter one, and it's the idea that we take a sample and use it to estimate the population. We're using samples in place of the population. And this is a more complex form of statistics. So, one way we do that is something called the confidence interval. So, as I said a second ago, a point estimate is going to have some error attached to it. And we call that a margin of error. Our book also refers to that as the error bound. The idea with a confidence interval is we'll find a point estimate, and then from that point estimate, we add and subtract a little bit of error because we know it could be a little bit on the low side or maybe a little bit on the high side. And that's what a confidence interval is. It's kind of a range of numbers that we're saying we believe that the actual parameter is in here. So there's no guarantee that we're actually going to capture the parameter, but we can actually make a pretty good prediction using probability. And I'll get more into that in just a second. The margin of error depends on how confident we want to be in our results. So, for instance, let's say I am using this apartment example back up here, and I'm finding these apartments, and maybe it happens to be the real busy season. So maybe apartments are getting rented like crazy, and the only ones that are left are kind of on the high end. So I think that my margin of error might be a little bit off based on that information. I'm going to be more confident that the mean cost of the apartment, of a two-bedroom apartment, is going to be close to what I'm coming up with as my estimate if I give myself more margin of error. All right, we'll talk more about that in a second. Before we do, Let's come down here and talk a little bit more about margin of error. When you read newspapers and journals, some reports will use the phrase margin of error, others will not use that phrase. But whenever we're using a point estimate, there is a margin of error, whether they report it or not. So let me give you an example of kind of how we would look at a confidence interval. And this is kind of how it often gets phrased. If a 95% confidence interval for the mean number of students that the students study per hour is 18 to 22. So what I want to know from this is, what is the point estimate and what is the margin of error? We're going to use, as I said in this book, they're going to use the symbols EBM for error bound. I can't remember what the M stands for. We'll see it in just a minute, but I will also put that down here so we know what that is. Okay, so we're going to find the point estimate from this interval. So this interval is including the error. So if it's all the way from 18 to 22, in the middle of this interval, that would be the number 20, right? So 20 is my point estimate. And since we're talking about estimating a mean, my point estimate is the sample that gave me 20. Therefore, to the 20, that kind of looks like a 6. Let me fix that. To the 20, we are adding and subtracting 2. That is our error. Now, you notice that they talked about a 95% confidence interval. What that means is that we are 95% confident that the actual parameter, the population mean, is between 18 to 22. Let me write that down. We are confident, or we are 95% confident, the population mean is between 18 to 22 hours. So we're talking about study time for students. So I'll kind of use the units they did. What that means is that we believe there's a 5% chance that we're wrong. So could we be wrong? Yes. Is there good odds that we're wrong? No. Being 5%, that's very low odds of happening. So it would actually be pretty rare if we were wrong. It would be kind of an unusual event. But there is a chance we're wrong, but we're pretty confident that in a 95% probability that we are in fact right. So they do mention this, that it's more accurate to state that the confidence level is the percent of confidence intervals that contain the true population parameter when repeated samples are taken. So meaning that as we keep taking samples, that about 95% of them are going to have the true population mean inside. Okay, that's another interpretation of the confidence interval, but we're going to kind of stick to this one. That's the most common. The idea that there's a chance we're wrong, but we're pretty sure we're 95% accuracy. Like we're feeling pretty good about it. There's a probability that we're 95% correct. Okay, so what I want to talk about is what we consider a good confidence level. So when you're saying that you have confidence in your accuracy, you typically want to be on the higher side. So the confidence levels that we will often look at, here I'm going to abbreviate confidence levels. We will often use 90%, 95%, 98%, and 99%. Those are the 4 that we're going to kind of stick with. So for each of those, we're implying that there's a chance that we're wrong, right? So when you're saying you're 90% confident, that means there's a 10% chance that you're wrong. Well, we actually have a symbol to represent the chance that we're wrong, and that we use the Greek letter alpha. So alpha is the chance that we are wrong. So in a 95% confidence interval, alpha is 5%, 98, it's 2%, and 99, it's 1%.